In this example, find magnetic field at O. This is a straight conductor, goes up to infinity. This is a semicircular portion of wire, and this is a straight wire, goes up to infinity. So we will call it as this portion number 1. This is portion number 2. This is portion number 3. For 1, see, for 1, this is a radius. Let us talk, this is the radius R, radius of the semicircular portion. First, portion 1, that is A to infinity, that is straight conductor, straight wire. See, Biot formula is dB is equal to mu naught by 4 pi into I into dl sine of theta divided by, here R is equal to R, we can write R square, where theta is equal to angle between radius vector and dl vector, because another form we can write dB in vector form is equal to mu naught by 4 pi into I into dl vector into r vector divided by r cube, or simply r cube. This first problem, this is the conductor, starting from A, it goes up to infinity, and this is point O. We are interested to find out at O what is the magnetic field produced by the current carrying this portion. This is R. Now see dl vector. If you take a small portion dl vector, and dl vector is along the direction of I. So this is the direction of dl vector. So dl vector is in this direction, and r vector also in this direction from here to here. So angle between dl and r vector theta is equal to 0 degree, and sine of 0 degree is equal to 0. So putting in this formula, therefore dB is equal to mu naught by 4 pi into I into dl into sine of this one is sine of 0 is equal to 0 divided by r square is equal to 0. Since small portion of magnetic field produced due to this current element, dl is equal to 0. It means every portion will produce 0 magnetic field on the line. It means, this already we have seen, the magnetic field on the line, on its, if a point P is located on a line carrying a current, the magnetic field produced is equal to 0. It means from here, anywhere, the magnetic field produced by this conductor at O. This conductor, magnetic field produced at O is equal to 0. It means first portion B is equal to integral of dB. Okay, B is equal to integral of dB, or B, since dB is equal to 0, summation of all magnetic field is also equal to 0 for the first portion. And second portion, it is a semicircular part. Already we have seen, for a semicircular part, the equation is for, that is AB. It is a semicircular part. What is the semicircular part? dB is equal to mu naught by 4 pi into I into dl into sine theta. Here the distance from here to here, this is distance is r square. What is theta? Theta is equal to, we can take it this way also. This is the, suppose this is the portion, this portion we written with respect to r. This is r, and this is dl portion, in this wire, and the angle between them is 90 degree. That way theta is equal to 90 degree, that is sine theta is equal to sine 90 is equal to 1. So theta is equal to 90 degree. Therefore dB is equal to mu naught by 4 pi into I into dl by r square. Sine 90 is equal to 1. We need not to write this one. Or B is equal to integral of dB is equal to, we can take mu naught constant, 4 pi constant, I constant, we can take r square also constant, integral of dl. What is integral of, see this is the length, this is dl, this is one more length. If we integrate the total length is equal to half of, see for this is semicircular, half of the circumference of full circle, 2 pi into r is equal to pi r. Because for full circle this is equal to 2 pi r, half the circle, half of the full circle is equal to pi r. So we can write B is equal to mu naught by 4 pi into I divided by r square into integral of dr is equal to pi into r. Therefore this equation can be modified into standard form. What is the standard form? B for any circular portion, B is equal to mu naught by 4 pi into I divided by r into pi, or mu naught into I divided by r. This will take angular portion outside, this is 2 into pi divided by 2 pi, pi divided by 2 pi, or we can write mu naught I by 2r into theta divided by 2 pi, where theta is equal to pi. It means where theta is equal to angle subtended with O at the with the angle subtended by circular portion, that is semicircular, circular portion with center O. What is the angle subtended? From here to here it is 180 degree. 180 degree means pi. Therefore we can simply write the equation as 4 pi. If we see any circular portion, we can write the equation, the magnetic field for the expression is mu naught by 2r, this is standard, into angle subtended divided by 2 pi. This already we have discussed, again I am reminding. So this is the equation for this. So for the second one, B is equal to mu naught I divided by 4r, mu naught divided by, because this and this get cancelled, and this get cancelled, mu naught I by 4r. And here we have the directions, because here the magnetic field is 0, that's why it does not have. We can write this way also, its magnitude is 0 and it's no direction. For the second one, direction means use the right hand thumb rule. The current is flowing this way and we enclose this one. We are interested to find out at this point it is going inside, at this point it is coming outside. So here outward, this is inward. So we are interested to find out at this point is inward. So the magnetic field direction, so it can be written as a vector like this. The third portion. Third portion is a straight line. That is, one portion is starting at B, another portion is ending at infinity. The third portion is, one portion is starting at B and another portion is ending at infinity. This portion, third one. See, already we have seen, if there is a straight wire, we take the perpendicular distance, that is A is the perpendicular distance with the conductor. With the conductor, this is the point here O, and we join one end and this angle with the reference line as phi 1, and another end we join with the reference perpendicular distance line O, and this angle is phi 2. Same way we proceed. One end is here, that is B is here, and another end is, already we have written, B is here. Suppose, what is the perpendicular distance? The perpendicular distance is from this point, from, see, we say any point, that is O. Here we are interested to find out from O, so we can write it from O. This is O. One end is here, that is B. Another end goes up to infinity. So this is O. This is the perpendicular distance, which is nothing but the radius, because this is the radius. So we can write A here. What is A? In this equation, the equation for magnetic field is equal to mu naught by 4 pi into I divided by A into sine of phi 1 plus sine of phi 2. Here A is equal to R. This is the perpendicular distance is AR. So this line, with this line we join one end, and with the reference line, this is the reference line, with the reference line we join one end, we have joined one end. What is the angle between the reference line and the line joining one end with the point O? That is 0, because this is the reference line and this is O, this is the one end B, and this is the reference line, and this is A is equal to R, and the same line, with this we join one more end. It means the phi 1, we can take phi 1 is equal to 0, because the angle between the reference line and the line joining O with respect to one end is equal to 0. It means we can say phi 1 is equal to 0. What about phi 2? Phi 2 means from here we join other end. So it means from here one end we have joined, another end we join, because it is at infinity. So at infinity, suppose if it is here, we can measure the angle as phi 1, phi 2. If it is here, it goes up to infinity. This line will keep moving like this. At infinity, this line will be like this. So the angle between the reference line, because this, when we move this line, it is, since it is going up and up, so the line will keep moving like this. So the angle between is 90 degree. That is phi 2 is equal to 90 degree. Okay, now putting in this formula, B is equal to mu naught by 4 pi into I divided by A is equal to R into sine phi 1. Phi 1 is equal to 0, sine 0, and phi 2 is equal to sine 90 degree. Sine 0 is equal to 0, sine 90 is equal to 1. Or we can say B is equal to mu naught by 4 pi into I by R. This is the magnitude of magnetic field produced at O due to the segment B to infinity. So there are three magnetic field at O. At O, this is producing a magnetic field which is equal to 0. In the semicircular part, this is producing a magnetic field at O, which is given by this one. And third one is B. Third one is B is equal to mu naught I divided by 4 pi R. So since it is a magnetic field, we have the directions also. So direction, what about direction? Current is flowing this way current is flowing. When this way is flowing, the right hand, the thumb, and we move it. So we are interested to find out what is magnetic field. This portion is going in. So the magnetic field here is cross and here is. This we are not interested. So this magnetic field is into the plane of the board by all the three segments of the wire. So since magnetic field is a vector quantity, we will add all the magnetic field in vectorially. So it means B net magnetic field in vector form is equal to B1 vector plus B2 vector plus B3 vector is equal to B1 vector is equal to 0 vector, null vector, plus B2. This is B2 is equal to mu naught I divided by 4R into the plane of the board plus mu naught B3 by 4 pi R into I. This is also into the plane of the board, or we can write it is, we will take common thing out, divided by 4R. This is equal to 1 plus 1 by mu naught I by 4R, 1 by 5, and adding this because both are in the same direction this way. So this is the expression for B net due to this portion, and this entire portion creating a magnetic field of B net at O.